Hi, I'm Rami Tamimi. Today we're going to try to find the elevation at the top of two buildings on this property. First, the elevation at the top of the house. Second, the elevation at the top of the shed. The surveying total station will allow us to take the difference in elevation between the point that we are referencing with a known elevation and the elevation at the top of both of these structures. We're going to be utilizing something known as prismless shots. Now, we're used to using prisms like this one to capture the data right at the center of the prism. However, not all total stations require you to use a prism. Some of them will allow you to take prismless shots on hard surfaces. The way this works is the total station will shoot out a laser, and that laser will then hit the surface, and the return pulse from that laser will be calculated, and that will be the distance from the total station to the surface. Now, we're going to want to use the same point every time. I think a good point to use for the house will be the top of this chimney. If we were to consistently shoot this point, we'll have a pretty good reading. And I think the same goes for the shed. If we were to go ahead and just shoot this corner right here, I think that's a pretty good spot, and we'll stay consistent with that. Now, for the first method, we're going to start by setting up over a point with a known elevation. If you don't know how to set up a survey total station, I've made a video about it. If you haven't seen it yet, please go watch it. It shows you exactly what you need to do to set this thing up so that you get accurate readings. We're going to set up over our infamous orange point with a known elevation of 602.662 feet. Now, in this first method, the first step is going to be to actually measure the instrument height. To do this, I'm going to be using a 20-foot tape to measure from the point to where the scope of this total station is. Start on 0 there. And it looks like the instrument height is at 4.88. 4.88. Okay, I'm gonna go ahead and take our observation at the top of the house. Go back. Okay, right at the top right now. And shoot. Okay, here's what we've got. Now, since we're comparing the change in elevation, the only number we're concerned with is VD, the vertical distance. That's the vertical change between the point we're set up on and the point that we sighted. And that number is 26.555. Now, given that the instrument height is at 4.88 and the vertical distance from the point we're occupying to the top of the building is 26.555, we can pull out our calculator figure out the elevation at the top of the building. To do this, we're going to take the elevation of point orange, 602.662. We will then add the instrument height, 4.88, and then we will add the vertical distance, 26.555. And the elevation at the top of the house is at 634.097. Let's go ahead and measure the top of the shed. All right. Move up, over, and I think right there will be good, and measure. And here we have a vertical distance of 7.455. Same concept, 602.662 plus our instrument height, 4.88, plus the vertical distance, 7.455, gives us an elevation at 614.997. That is the elevation at the top of the shed. Now, for the second method, what we're going to do is set up the total station in an arbitrary location. We're going to then backsight a known reference point. We're going to use the same reference point just to stay consistent. And then we will foresight the top of the house and then the top of the shed. So this is now just an arbitrary location, nowhere specific. I don't know the elevation over here. I'm just gonna level out the total station so that we can have accurate measurements. Now that our total station is completely level, we're going to set up a prism on our backsight. Since we don't know the location of our total station, we need to then backsight to a point that has a known elevation. So, elevation of orange, 602.662. We will use this elevation, and based off of the Backsight that we take, it'll calculate our instrument height. This is exactly what we did in the elevations and surveying video. If you haven't seen that video, I recommend you watch that. It goes more into depth about what I'm about to do now, using a Backsight elevation to calculate the instrument height. From our instrument height, we'll then take two prismless shots, one foresight on the house and one foresight on the shed. So I'll set this rod up real quick. And remember, we're going to need the height of this rod to be recorded. So I'm gonna raise this up till 6 feet. All right, and lock that into place. Now we're gonna take a Backsight to orange. Okay, and good. And we have a vertical distance between the arbitrary point we're set up on and the referenced orange point of negative 0.385. Now let's go ahead and calculate what the elevation of our instrument is. So we're going to start by taking the elevation of the orange point, 602.662. We will then add the rod height of 6 feet minus a negative 0.385 for the vertical distance. Remember, minus negative is addition, so you're going to be adding them technically. And we get an elevation for our instrument height of 609.047. Now I'm going to take two foresights, one at the top of the house. Okay, good. And we have a vertical distance of 25.065. And finally, we're going to take one more foresight at the top of the shed. Okay, and good. And a vertical distance of 5.955. All right, let's go ahead and calculate the elevations one more time. So we're going to take our instrument height of 609.047. We're then going to subtract the prism height, but since this is a prismless shot, the rod height is technically 0. And then we're going to add the vertical distance of 25.065, and our answer is 634.112. Now in the first method, our calculations came out to 634.097, meaning our error is 0.015 feet, which that's pretty much right on. So that is the elevation at the top of the house. To calculate the elevations at the top of the shed, 609.047, we'll then add our vertical distance of 5.955, and we get 615.002. And when we did this the first method, we had 614.997, and our difference is, Jesus, our difference is so small, it's 0.005. I mean, so we're right on. Our accuracy is perfect. And that's it. That is how you can calculate the elevation at the top of a building using a surveying total station. I hope you guys enjoyed today's video. If you did, be sure to like the video, subscribe to the YouTube channel if you enjoy surveying content and want to see more. If you have any questions, go ahead and email me. My email is below as well. And with that, I will see you guys next time.